From core to cloud, learn how EPAM is laying the groundwork for Shell's Gen AI-powered Geoscience future in this AWS Energy Symposium exclusive interview. To help us explore this groundbreaking journey, Mikhail Gurevich, Chief Technologist for Energy at EPAM, and offering the broader strategic and technological vision, Max Liu, Innovation Lead in Subsurface Innovation at Shell, who brings a crucial perspective from the front lines of subsurface division. What specific challenges with Shell's on-premise infrastructure for geoscience computing motivated their shift to cloud-native HPC?
Our journey actually started quite a while ago, back in 2015, right? So this was before most people knew what Gen AI or ChatGPT was. But at that time, we still had this very, I would say, visionary vision to understand the promises of the cloud. Right? At one point, we really brought into the vision of elastic compute, right? Being able to run workloads very quickly without a lot of infrastructure investment. We also looked at things like bringing on board a lot of bandwidth for HPC capacity within a shorter timelines. And we also saw that this was potentially going to shape up to be an ecosystem where we can have a lot of partners and other vendors that we can tap into to really accelerate our progress in our subsurface leadership story. Right, and today we see some of those things really play out in reality, right? And today, obviously 10 years ago, we didn't have Gen AI, but now that has become really a leading story here for us at on the cloud AWS.
Yeah, I want to add to that and this is something that we see across all our client network, is that up to this point, up to probably a year ago, so migration to the cloud was primarily cost-driven conversation, which in rare cases actually favored the cloud. But since recently, we got this killer application. So cloud's got its own killer application, which is enterprise Gen AI, which you cannot get at scale anywhere else, which kind of restarted this whole conversation at a different level and compelled many customers, and Shell included, to move faster. So as Max said, they've been moving for quite a while. So this is a conscious decision and very well thought of decision. But what accelerates it is this killer application that we now get on the cloud.
Beyond the technical migration, how does the integration of domain-specific AI and Gen AI within this cloud HPC initiative contribute to Shell's broader digital ambition and transformation of decision-making?
AI and Gen AI, and in the recent couple of years, agentic AI are very exciting capabilities that is very difficult, I think, for big organizations like ours to ignore. Right? And certainly we've have ambitions in this space, and you may have even read some of our published papers on this topic in the past. We've had research into Gen AI, we have efforts into Gen AI. And how does this link to the cloud? Well, I have a bit of an anecdote about a recent subsurface team who moved one of their Gen AI discipline-specific topics from an on-premise resource to a cloud resource, right? So on-premise GPU compute capacity to cloud GPU compute capacity. And when I presented this to the project lead at the beginning, I'm like, hey, can you move to the cloud in a few months? There's a lot of hesitation, a lot of pushback, right? Because people are afraid of kind of the new thing. They want to go, with what they're used to, and instead of trying to go to the unknown, right? When that transition happened, and I didn't expect this, but within a few days, I got a message from the guy. He's like, hey, Max, today I feel like a kid in a candy store, right? And it's sort of these candy store moments where we're going to have researchers, right, really grasp all the possibility out there without being limited to, restrictions that you may face on premise. I think that's really powerful. And having that ability, I think, will help us continue to drive subsurface leadership.
Yeah, and on a technical level, what I might add to that is that if you want to deploy Gen AI at scale in your enterprise, so it needs the ability to leverage all the capacities that you have. And HPC, specifically geoscience capacity, is one of the crucial things that run Shell's business. So if you don't have this ability, then you're Basically, you're not extracting value from Gen AI. So one of the things that the system that we deployed does, it introduces the common language among all the geoscience capabilities for Shell, which allows agentic infrastructures, Gen AI infrastructures to leverage it without much integration effort. So this exposes previously locked in functionality, very valuable functionality that was locked in into this scientific silo to the broader enterprise context. So that's exciting, yes.
Which is a key theme here at the AWS Energy Symposium is enterprise modernization. But when you're taking an idea and then making it into reality, there are some key challenges and learning opportunities that happen there. Can you shed some light on some of those?
I mean, if I had to name one, is that what the big language models and for traditional software, the problem of integration, understanding what software does, its capabilities, and ability to leverage it is very hard to achieve. It's almost like people, you feel, you hear it across the board that people spend 90% of their time preparing the data, getting the data, doing this, doing that, before they can be productive. So one of the challenges that I think we solved pretty elegantly is to normalize and put like a single pane of glass on top of all the algorithms that are very disparate in their nature, and that requires the combination of both domain expertise and a lot of computer science. So I think that's the most exciting aspect of that.
Can we go back to the beginning of the inception of this idea for the HPC orchestrator? What was the main starting point for this? Like, what was the why behind why this was created?
I mean, this has always been an idea in the industry. Like, can we take these common platform pieces, and instead of each individual organization trying to build their own version of the same Lego piece, can we actually have experts with deep capability in these fields build the common Lego pieces, such that we can then add our own geophysical subsurface expertise on top, right? Because we fundamentally believe that our value add is not necessarily in the work. We're not competing against EPAM in building these platform pieces, right? We're here to do geoscience and perform subsurface work. So, I think 2 years ago we sat down together with some of our partners in a working backwards session and in the office here in Houston, and we sort of did it was my first time doing a PR FAQ. I did this kind of, hey, we start with the problem and then define the solution at the end sort of process. That was the inception of this, right? This kind of cross-organizational, cross-discipline collaboration for us to build a common platform and common ecosystem that allows vendors and academics and industry to all participate and gain value out of.
Yeah, and from our perspective, when we came into this, what was the most appealing is that what we're trying to do on the grand scheme of things is to move energy enterprises to the cloud. And there's always been this source of friction when you go from the enterprise capabilities into hard science,
right?
Especially HPC. And also there was this universal desire among our clients to use best-in-class software, which kind of implies that no single vendor can cover your needs. And this whole idea of putting together essentially a uniform service layer that would unite all those disparate pieces of functionality and do it on the cloud goes very much towards our goal of enabling enterprises to migrate themselves to the cloud.
I would call this almost like a new era, right, for the energy industry, especially with like this offering. What are some anticipated benefits of this shift to intelligent, data-driven energy operations for Shell? Like we said, like in this new era, particularly concerning exploration and the energy value chain.
That's a good question. We are always in exploration, you're always at the frontiers, right? And I think the frontiers are not getting easier. So the challenges, the data challenges are growing. And one of the ways around this is for us to be more quantitative in our decision making. And what we can do there is, if we have this capability to run our workloads faster, right, cheaper or better or more accurately, we can take a look at more diverse set of scenarios that then allows us to better capture the uncertainty that we are faced with today in subsurface, and hopefully that way make better decisions when it comes to performance.
So let me build on that a little bit. So when you're talking about this ability of iterating and running multiple things, so technically speaking, scientifically, this is a prerequisite for you to be able to optimize things. You have to see at least a couple of options before you can choose. So there were several things that would prevent people from doing that. First is that your capabilities that you need in the whole workflow were siloed. So it was very long process and largely manual process. So what you need is you need to break the silos and integrate things. The process is still very complex. So without automation, it's prohibitively expensive and long to try to iterate and optimize. So by breaking the silos and then enabling the automation all the way through, potentially automation, of course, driven by the AI. So I think that's a holy grail, for enterprise decision making. That's where everyone's trying to get to.
And de-siloing is an ambition that people have for a very long time, but it's very difficult to achieve, right? So especially for different, very distinct disciplines like geoscience and reservoir engineering, for example. So how do you really remove the boundaries in those two types of workflows? And one way potentially is to have this kind of common ecosystem, right, where teams can see what each other is doing, and workflows and products are well integrated from the get-go. So we certainly see EHO as having the potential to really help us along this de-siloing journey.
Yeah, that's not a complete solution, but that's a very good step, and it's almost like a proof of concept.
Yeah.
So if we did it for HPC Geoscience, we must be able to do that for the rest of it. Yes.
If other organizations are looking to migrate high-performance computing to the cloud and integrate advanced AI capabilities, what should they take away from this collaborative effort between EPAM, Shell, and AWS?
In a lot of ways, what the AHO promises is transformational. And when you're looking at really big disruptions to your ways of working, you have to, by definition, be ready for things to break, right? Be ready for your traditional ways of working to break a little bit. And there's the technical aspect of that, which is very important, but then there's also the behavioral aspect that I think is equally as important to address. You really have to ask yourself, are my teams and is my organization ready for this change? But to speak of the collaboration between the three organizations, I think what made this very successful is that we are very much aligned in what we want to achieve in our ambitions. Right? What the value drivers that we all have are very complementary. And then we recognize and respect each other's skill sets. Right? So, we're not having EPAM do geophysics, and certainly I don't want to do this kind of stuff that Mikhail's good at. So, all those things come together, I think, to have a very successful collaboration.